Welcome to the End Unit 6, Quiz Number 2, Read Aloud. If you need some more time between questions, please pause the recording. Right, here we go. Question number 1. Your favorite recipe for preparing 100 brownies requires the following: 6 eggs, 5 cups of flour, and 2 sticks of butter. How many eggs would be required to yield 50 brownies? 2 eggs, 3 eggs, 4 eggs. Question 2. In the balanced reaction below, what is the mole ratio comparing iron and oxygen gas? We have 4 Fe plus 3 O2 yields 2 Fe2O3. Is the ratio 4 to 2, 1 to 3, or 4 to 3? Question 3. Which of the conversion factors below is the centerpiece or middle step of every stoichiometry problem? Molar mass, mole ratio, Avogadro's number. Question 4. Which conversion factor is needed to solve the following problem? How many liters of ammonia gas can be formed from 60.4 liters of hydrogen gas at STP? The equation is 3H2 plus N2 yields 2NH3. Molar volume, the molar mass of hydrogen, the molar mass of ammonia. Question 5. How many liters of ammonia gas can be formed from 54.1 liters of hydrogen gas at STP? Let me read that again. I skipped over that first part. It says, which of the mole ratios would be used to set up the below problem? How many liters of ammonia gas can be formed from 54.1 liters of hydrogen gas at STP? We have 3H2 plus N2 yields 2NH3. Is it 3 moles of hydrogen over 1 mole of nitrogen, 2 moles of ammonia over 3 moles of hydrogen, or 1 mole of nitrogen over 2 moles of ammonia? Question 6. Choose the answer below that is an important step to determine the number of grams of SO3 sulfur trioxide that can be produced by reacting 6 moles of sulfur dioxide with oxygen in the synthesis reaction below. Hint, it would be helpful to set up this problem the way we have done in class so you can choose the best answer. The equation that goes along with it is 2SO2 gas plus O2 gas yields 2SO3 gas. Multiply the number of moles given in the problem by Avogadro's number to find grams of SO3. One needs to find the molar mass of SO2 and the mole ratio of SO2 to SO3 and set up a mole mass problem. Multiply the molar mass of oxygen by the number of moles given in the problem. Question 7. What is the mole ratio of lithium hydroxide to carbon dioxide in the reaction below? We have 2 LiOH, lithium hydroxide, plus carbon dioxide yields lithium carbonate, Li2CO3, plus water. Is the ratio 2 to 1, 3 to 2, or 2 to 2? Question 8. We want to produce 4 moles of ammonia. How many moles of nitrogen would be required? We have N2 plus 3H2 yields 2NH3. 5 moles, 2 moles, 4 moles. Question 9. Choose all of the statements below that are true about Avogadro's number and the mole. Avogadro's number is to the mole what 12 dozen is, or what 2 is to a pair. Let me read that again. Avogadro's number is to the mole what 12 is to a dozen, or what 2 is to a pair. A mole simply means 6.022 times 10 to the 23rd of something, atoms, molecules, or particles, or Avogadro's number is 6.022. Again, choose all that apply. There could be more than one answer. Question 10. In the synthesis reaction below, calcium reacts with nitrogen gas to produce calcium nitride. Choose all of the statements that are true about it. The reaction is 3Ca calcium plus N2 yields calcium nitride Ca3N2. If you double the amount of nitrogen used in the reaction, you will triple the amount of a product used. The ratio of calcium to calcium nitride in the reaction is 3 to 1. For every 1 mole of calcium nitride, you need 1 mole of nitrogen gas. Question 11. Think about how to determine the molar mass of ammonia hydroxide, NH4OH, ammonium hydroxide, NH4OH. In that amount of ammonium hydroxide, how many moles do you have? 1 mole, 4 moles, 0.5 moles. Question 12. Match the term to the number it represents. We have 6.02 times 10 to the 23rd, 14 grams, 22.4 liters per mole, 32 grams. We have molar volume, 1 mole, molar mass of oxygen, molar mass of hydrogen. Question 13. In a particular stoichiometry problem, you are asked to find the number of moles of a reactant that will form 3 moles of one of the products in the reaction. Which of the following conversion factors would you use for this problem? The molar mass of the reactant, the mole ratio from the balanced equation, the molar volume. Question 14 is an open-ended question. It says, calculate how many grams of zinc chloride are produced if 6.5 grams of zinc is used to react in the chemical reaction below. Be sure to show all of your work. Again, this is a math problem, and the reaction is zinc plus 2 HCl, 2 moles of hydrochloric acid, yields 1 mole of zinc chloride plus 1 mole of hydrogen. Again, be sure to show all of your work. Pause the recording here to complete the problem. Question 15. Did you ever wonder how a camel can survive in deserts where there's little or no water? For them to drink, you may have heard that they store water in their humps. That isn't exactly true. They store the fat triceratin in their humps. The formula of this fat is C57H110O6. The chemical reaction takes place in the hump to produce water as shown in the reaction below. We have 2 C57H110O6 plus 163 O2 yields 114 CO2 and 110 H2O. The following problem is worked out below. How many grams of water can be produced with 1,000 grams of C57H110O6? Use the chemical equation, the question, and the problem set up to answer the following questions. Be sure to show your answer for all numbers 1 through 5. This is the worked out problem. Question number 1, what is the given in this problem? Question number 2, true or false. The problem is asking you to find the moles of oxygen needed in the reaction. Question 3, which of the boxes in the problem setup is the mole ratio? Question 4, in the box that's labeled D, how is the 18 grams of water determined? And then finally, number 5, how many grams of water are produced? In other words, grab your calculator and solve this problem. Again, pause the recording here to answer. We have one left. It's an extra credit or bonus problem. Again, this is optional. It's worth 10 points. You have to show all of your work to get full credit. It says how many grams of water can be produced from 45.2 liters of oxygen gas. Again, you must show all of your work. That is the end of the test. If you have any questions, please let me know, and good luck.